In this section, we're going to analyze observational studies and experiments. Observational studies and experiments are things that we have both done at this point. When we're thinking about an observational study, we're usually thinking of a sample survey, something that would have happened back, let's say, in Unit 2, where you would go out and do an SRS of the population and try to understand something about the entire population from collecting data from just a sample. Now, previously in Unit 2 we had done observation studies on a single variable. In Unit 4 we did a special type of observational study that involved two variables at the same time, where we would plot points that we observed from both variables, and that was when we studied scatter plots. So you are able to then analyze that data and find how well that data fits together and what kind of trend lines. We also, in this current unit, have looked at certain experiments that don't allow you to randomly assign people to different treatments. For example, if you're studying gender, you're not able to randomly assign the gender of a person. So, as a result, the best you can do is just to look at the results of comparing, let's say, men and women. You aren't able to figure out what causes it, you're just able to identify that link. Same problem we ran into when we looked at scatter plots. When we had two variables, we never could tell which one caused which simply by looking at the graph. We would have to think through the two variables and say which one would logically cause the other. Maybe there's something else in the background causing it. The graph doesn't tell us the cause. That's the key to an observational study. You're taking a step back and you're looking at a pattern, you're looking at data you've collected and trying to make an observation. This seems to be like this, or this seems to be linked to that. An experiment, on the other hand, is all about the causation, figuring out what causes what, because we can control everything about this process. We can get rid of lurking variables. Whenever we have an experiment, we're always looking at two or more treatment groups. We always need to compare it to something, and that's how we get rid of those lurking variables, is by comparing two things that are very, very similar, but only varies by one very specific thing. Now, the subjects or experimental units are randomly assigned to those treatment groups. So we have treatment group 1, 2, and let's go ahead and make 3 for this example here. We have people randomly split into these three groups such that before we apply any treatments, we're assuming that all 3 or all 2 or all 5 or however many treatment groups you have are equal. The people in those studies, because they've all kind of been randomly dispersed, are effectively going to be equal. Then we go out and we look at our treatment groups and we apply some treatment to them, and each treatment's a little bit different. Maybe one's taking a certain type of pill, one's taking a different type of pill, and one is taking a placebo or a fake pill. Then the only difference between these groups after the treatment is the very specific thing that we wanted to study. That's why we can find a cause. So looking up in the corner here, whenever we're trying to find a link between things, both observational studies and experiments will do that. They will find that this variable is linked to that variable. So we can drag that over here, drag that over here. Both of these will find a link. When we want to find a cause, an observational study will not tell us the cause. We need to do an experiment to be able to find a cause. Typically, the way things will work is you'll do some kind of observational study first to figure out what things are correlated, what things fit together. And once you've identified things that seem to fit together, you try to make sure what the cause is. You have a prediction of the cause, a hypothesis, and you design an experiment to confirm that or find that no, it's actually something else. So the experiment typically will confirm something that you've observed in some other way. If you've observed that there's a link between smoking and lung cancer, you might design an experiment, probably not with humans for ethical reasons, but design some sort of experiment that will show that one can cause the other. Let's go through some examples and try to figure out whether it is an experiment or observational study and how correctly it is being done. A student group takes an SRS of students on a college campus. So we have a student group doing some kind of study. They take an SRS of college students on campus. They ask the students if they have been to a new local restaurant or not. So they go up to students and they have a question. Have you been to the new local restaurant, or have you not been to that new local restaurant? Then they ran an advertising campaign for 3 weeks to make students aware of the new restaurant. So this is the thing that they did. And then at the end, they took another SRS to see if the advertising helped. So they measured before and they measured after. And they're comparing those two results. There's the before and the after measurement, and they want to compare that data. Is this an experiment or an observational study? How do you know? The important thing to realize is that if it doesn't have all of the elements of an experiment, a correctly done experiment, you're looking at an observational study. So there is no random assignment. There is no control group that people are being put into. They don't have a group of people that are not advertised to and a group that is advertised to. They collect data, they advertise to everyone, and then they collect data again. The reason that's not an experiment, like I said, besides that control and randomization part, is that other lurking variables could get mixed in. Who knows if it turns out that the restaurant just opened the day before, and so nobody had, of course, really been to it, and even without the advertising, word of mouth would have caused this restaurant to catch on and become popular very quickly. There's no way of knowing if it was the advertising that caused, people to start going to this restaurant, or was it something totally unrelated? Maybe the second favorite restaurant on campus shut down, and all of a sudden, therefore, everyone started going to this restaurant. You have no way of knowing because you have no control group and no randomization of how people get put into that group. So it is not an experiment. It is an observational study. The reasons we know that, again, there's no control group, no randomization, and lurking variables can get mixed in. Is this study done correctly? So we know it's not an experiment, but whenever it's an observational study, you have to make sure that the people are being randomly picked from the entire population. It says here, when they picked their people, they took an SRS of students on campus, and at the end they took an SRS of the students on campus. So whenever you're doing an observational study, if you want it to be representative of everyone, an SRS is a very good method to determine who you're going to collect data from. So I would say yes, SRS would mean done correctly. Scroll down one more question. The population under study in this observational study here is the students on a college campus. So whatever college campus we are on, we're looking only at that campus. We are looking only at students, and that is our population under study. So let's go on to a second example. Math department wants to know if students perform better or worse on tests when they are listening to music. One teacher asked for students who would be willing to participate. Of the volunteers, he randomly divides half to listen to a music device while the other half does not. He compares the resulting scores after the test. So to clarify this, there is some sort of study. The teacher wants to see how students perform differently based on listening to music or not during a test. And of the students who volunteer to participate, let's assume that all of the students who volunteer would have to be willing to do one or the other, to either listen to music or not listen to music. And randomly divides half of them to be in one treatment, half of them to be in the other, and then compares the results. Is this an experiment or not? Well, since there are two treatment groups, let's use a different color here. If there are two treatment groups, there is the music and the no music group, there is a comparison, there is a control. The control would be probably considered the no music group. And everything about these groups is going to be exactly the same, except that one is listening to music, one is not. To make sure that the groups ahead of time are equal, there is random assignment. So randomly half of them are assigned to one group and randomly half will then be assigned to the other. So the two treatment groups are effectively equal until the one difference, music or no music, is applied. So yes, this is a valid experiment. It is not an observational study. The reason we know, like we just said, there is a control group and people are randomly assigned to that group. Is the study done correctly? Well, yes, it is. We don't just have an experiment, but we have a valid experiment. Now looking at the volunteer situation, it says we're taking volunteers, and remember that volunteers are okay in an experiment because that means that they're being randomly split up between the two or more treatment groups, so the results are still valid. If all the volunteers were males, or all the volunteers were somehow different than the other people in the class, then you might have concerns that the results, though valid, only apply to males or only apply to some specific group of students and not to all students. So you do have to be careful about volunteers, but the results will still be statistically valid. So I would say that this experiment is done correctly from the information that we're given. The population under study here is students in this one math class. So it's only one teacher doing this. So it would only be students in this one teacher's math class that would be under study. And then the last example we're going to look at, political organization is studying the link between gender and voting preferences. They collected a set of volunteers to participate in the study. The organization tracked the gender and preference, voting preference that is, for each person. At the end, they compared the results. To identify if it's an experiment or observational study, we're looking for the key attributes of an experiment. Are there multiple treatment groups, first of all? And it says they're studying a link between gender and voting preference. So they have a set of volunteers and they looked at their gender and their voting preference. So first of all, they're assuming that the cause is going to be gender. So they're splitting people up into a group of males and a group of females, and they're comparing their voting preferences in some way. Now the problem is that even though there is two groups and you can compare these two groups, you can't randomly assign to these two groups. These two groups were set up this way well before the study. So in order to do a proper experiment, you need to make sure that you randomly assign. So that is now out. The best you can do to study gender here is an observational study. It could be something related to gender that causes it, but there could be other causes going on that are linked to gender that you wouldn't know about, other lurking variables that you can't filter out because you can't randomly assign. So we're looking at an observational study. The reason is that we can't randomly assign to our treatment groups. And is this study done correctly? Whenever we're looking at an observational study, we're looking at making sure we have some sort of SRS of the population that we're studying. And it says they collected a set of volunteers to participate. Whenever you're doing an observational study with volunteers, you're basically setting yourself up for useless results. So in this case, no, the study is not done correctly. The study is not going to be very valid for anything. Imagine if you just walked up on the street one day and decided to maybe walk into a very Republican-heavy restaurant, and you started taking volunteers to be in your study. You're going to all of a sudden notice that whether you're male or female, the link seems to be to being conservative. Or a place where there's lots of conservative men and liberal females, then you're going to all of a sudden see a link between gender that doesn't really exist in the general population, but does exist in the small set of volunteers. So the voluntary thing is going to make your observational study worthless. Population under study. The population they want to study doesn't actually get specified up here. My guess from the context is that they're probably looking at a state or a country at a time, but it really doesn't make a huge difference because of the fact that it is in fact voluntary. Their results are going to be pretty worthless anyways, so we might put USA question mark. But in the end, like I said, it's not going to really matter much because it isn't a valid study.